children, looking into the problem given on the board for the chapter coordinate geometry, it is show that the points A, B, C and D form the vertices of a rhombus. How do we decide that these vertices are or can be called as the vertices of a rhombus? Definitely after calculation of all the pairs of the vertices given over here or points, the four sides that we get or the four distances between the different pairs of points that we choose should be equal. That is, distance AB, distance BC, distance CD and distance AC that we calculate should be equal. Only then we can say that they are forming the vertices of a rhombus, as all the four sides of a rhombus are always congruent. So to begin with, first distance AB with the same distance formula, x2 minus x1 the whole square plus y2 minus y1 the whole square. Let's assign the values for x1 y1 and x2 y2 as we have chosen A and B. Let's assign x1 y1 to the coordinates of point A and x2 y2 to the coordinates of point B. To move on with the substitution, in this next step, distance AB will be equal to square root of x2 is minus 1 minus x1 is minus 4 the whole square plus y2 is 2 minus y1 is minus 7 the whole square. To continue, distance AB with mathematical steps ahead. Let's solve what is given in the first bracket. Minus 1 minus into minus gives us plus 4 the whole square plus 2 minus into minus is plus 7 the whole square. So distance AB will be equal to minus 1 plus 4 gives us 3 the whole square plus 2 plus 7 gives us 9 the whole square. So distance AB will be equal to 3 square that is 9 plus 9 square that is 81. So distance AB will be equal to square root of 9 plus 81 is 90. Let's factorize 90 as 9 into 10. And we know, children, square root of 9 is 3. So distance AB will be equal to 3 root 10 units. Or in other words, we can say that length AB is equal to 3 root 10. So let's write it down. Length AB gives us 3 root 10 as the answer. Let's move on now to calculate distance BC. Again with the same formula, but let's assign the new coordinates as x1 y1 and x2 y2 for which points? For points B and C. So over here for point B, we will have the coordinates assigned with the value x1 y1 and C with x2 y2. To begin with the calculation part, distance BC will be equal to x2 that is 8 minus x1 that is minus 1 the whole square plus y2 is 5 minus y1 is 2 the whole square. So distance BC will be equal to square root of, let's solve inside the bracket, 8 minus into minus gives us plus 1. So 8 plus 1 the whole square plus 5 minus 2 gives us 3 the whole square. So distance BC will be equal to 8 plus 1 is 9 plus 3 square is again 9. So distance BC, to solve further, let's square 9 that is 81 plus 9. So distance BC will be equal to 81 plus 9 gives us 90. Let's factors of 90 to be put up. That is again 9 into 10, and then we already know square root of 9 is 3. So 3 root 10 units. So we saw, children, in this case, this length AB also was the same, that is 3 root 10 units. Distance BC, that is length BC, is again 3 root 10 units. So we saw in the first case and the second case, both the answers were the same. Now, what do we calculate further? We are left with distance CD. So distance CD, again with the same formula, x2 minus x1 the whole square plus y2 minus y1 the whole square. Let's assign the coordinates of C and D as x1, y1 and x2, y2. So for point C, x1, y1, and for the point D, x2, y2. To begin with the calculation part, distance CD will be equal to square root of x2, that is 5, minus x1, that is 8, the whole square, plus y2 is minus 4, minus y1 is 5, the whole square. So over here, distance CD will be equal to square root of 5 minus 8 is minus 3, the whole square, plus minus 4 minus 5 gives us minus 9, the whole square. So distance CD will be equal to minus 3 the whole square gives us minus 3 into minus 3, that is 9, plus minus 9 the whole square, minus into minus is plus, 9 9s are 81. So distance CD will be equal to 9 plus 81 under the square root sign gives us again 90, which can be factorized as 9 into 10, and square root of 9 is 3. So that is 3 root 10 units. That means over here, children, the third length or the third side gives us the same answer. That is length CD is equal to again 3 root 10 units. So we have done with the three sides. We are left with the last side, that is AD. Again with the same distance formula, let's assign their coordinates as x1, y1 and x2, y2. As we are dealing with points AD, let's assign for point A as x1, y1 and for point D as x2, y2. To begin with, distance AD will be equal to x2. x2 is 5 minus x1 is minus 4. The whole square plus y2 is minus 4 minus y1 is again minus 7. So let's put it correctly inside the bracket. So distance AD will be equal to 5 minus into minus gives us plus 4 the whole square plus minus 4 minus into minus gives us plus 7 the whole square. To move on with the calculations, distance AD will be equal to, in the first term, 5 plus 4 gives us 9 the whole square plus minus 4 plus 7 gives us 3 the whole square. So distance AD will be equal to 9 square, that is 81, plus 3 square is 9. So children, if we see properly, again we are getting distance AD as root 90. Root 90 can be split up 90 can be split up as 9 into 10, which further gives us again root 9 is 3. So 3 root 10 units. So again children, in the last case, length AB was again 3 root 10 units. Now, in the last segment, we have to decide if these points A, B, C, D form the vertices of a rhombus. So let's check with the answer. What is the answer? What is the length of all the four sides? Yes, the answer for all the four sides are equal, that is 3 root 10 units. So what do we write? As length AB is equal to length BC is equal to length CD is equal to length AB. The 4 points A, B, C and D are the vertices of a rhombus. So why did we call it as the vertices of a rhombus? Because after calculations we saw that all the four sides making up this quadrilateral are equal, or the four sides are congruent, therefore the given quadrilateral is a rhombus. That means, in other words, A, B, C, D points are definitely the points or the vertices making up this rhombus.